following example problem that we're going to perform ties together a lot of the concepts that we've been looking at from this section of the textbook. And it is as follows. Freon 12 has been used as a refrigerant and an aerosol propellant. It is prepared by the following reaction. 3CCl4 plus 2SbF3 giving 3CCl2F2 plus 2SbCl3. When 115 grams of CCl4 and 115 grams of SbF3 react, 80.0 grams of CCl2F2, or Freon 12, was recovered. Calculate A, the limiting reagent, B, the theoretical yield, and C, the percent yield. So, in order to calculate our limiting reagent, or limiting reactant, we have to first start with the mass given for each of the reactants. So the first calculation is we're going to take the 115 grams of CCl4 and convert that over to moles of the Freon 12. So from the periodic table, we know that 1 mole of CCl4 is going to be equal to 153.8 grams. From the balanced chemical reaction, for every 3 moles of CCl4 that are consumed, 3 moles of the CCl2F2 are produced. This is going to produce a total of 0.748 moles of the Freon 12. Likewise, we need to do the same calculation for the 115 grams of the SbF3. We know from the periodic table that 1 mole of SbF3 is going to equal 178.8 grams. From the balanced chemical equation, for every 2 moles of SbF3 that are consumed, 3 moles of CCl2F2 are produced. This is going to give us 0.965 moles of CCl2F2, or Freon 12. So from these values, this first one that we calculate is the smallest number of moles. So therefore, the CCl4 is the limiting reactant. Since we know that that's the limiting reactant, we're going to use that 0.748 moles to calculate the mass of the Freon 12 that's going to be produced. So we just need to do one more step, which is 0.748 moles of CCl2F2. Using the periodic table, 1 mole of the Freon 12 is going to be equal to 121 grams. And that's going to give us a value of 90.5 grams of CCl2F2. So this value right here is our theoretical yield. So that is part B for our problem. Part C is to calculate the percent yield. And remember, the percent yield is going to be the actual yield divided by the theoretical times 100%. And for this particular problem, the actual yield we determined in the lab was 80.0 grams divided by 90.5 grams, which is the theoretical yield, times 100% is going to equal 88.4%. And this is our percent yield. So that answers part C of this particular question. So to sum everything up, we were given a balanced chemical equation, and we said that 115 grams of each reactant were able to react. We were able to recover 80 grams of the Freon 12. From this, we can calculate the limiting reactant, So we convert over to the moles of the product for each of these reactants. Then, once we figure out which one the limiting reactant is, we take the number of moles produced from the limiting reactant, convert that over to grams, and that gives us our theoretical yield in grams of the product of interest, which in this case is our Freon 12. Lastly, we can calculate the percent yield because in the problem we were given the actual yield that was recovered in the laboratory, divided by the theoretical or the calculated value in grams times 100%, and that gives us a percent yield of 88.4%.